Okay, let's start this session on Candid. Sorry for the delay. Now I'm getting ready. So we have already talked about Candid. We have already seen it, but we haven't had time to really focus on it and just talk about it from the beginning, from like why it was created to how we use it and how it interacts with Motoko, how it interacts with JavaScript and other languages. So Candid can be considered the language of the internet computer because this is actually how canisters communicate between each other. And it's one of the technology that was created as part of the ICP like research effort that was going on from 2017 to 2021 when Definity created the ICP. And Candid and Motoko are very related technologies. They were created by the same teams around the same time. So you will see a lot of similarities. Why do we need Candid? We need Candid because the vision is that on the IC we can code with any language because the canisters are WebAssembly module and almost any language could be compiled to WebAssembly. So we have Rust, we have Motoko, but we also have TypeScript, we also have Python. There is a little difference because TypeScript and Python, they don't necessarily compile directly to WebAssembly, but they have a runtime that compiles to WebAssembly. And so essentially you can install the runtime in the canister and have the JavaScript interpreted inside the canister. But in the end, you can still write a canister in different languages. And so how do you communicate between canisters if you don't have the same representation? Like if you want to send a call to another canister, you want to use a square function. So this is the example that I'm giving here. You have a natural number in Motoko, and you want to use a square function on it, but the square function is written in Rust, in a Rust canister. The problem is that the nat number Motoko doesn't relate necessarily to a type in Rust. So I'm not a Rust expert, but I found out that you have this type U128 that would correspond, but in Motoko it doesn't exist. So it's like trying to communicate in Spanish to someone that speaks Chinese. Oops, my bad. Let me deactivate that. And communicating between canisters that are written in different languages is really one of the central vision of the internet computer. So that's where we come to the term interface description language. An interface description language is a language that is used to communicate from one program to another program. So in that case, from one canister to another canister. And Candid is an interface description language that describes the interface and the types of all canisters deployed on the internet computer. So essentially, a canister in Motoko will have types, a canister in Rust will have types, and those types will match to a type in Candid. And that's how they can understand each other. The Candid file .did is really important to understand how Candid works and how canisters generate this file. So if I take a look at the DFX project, so I'm going to generate a project. We haven't done it this way yet. This is the first time, but you can generate a project by running DFX new and then whatever name you want for your project. So let's remove it. This will generate a template project. In Motoko, you have also a template project in Rust. If you want, you just need to add the type Rust flag. And this project has a front end and a back end. So this is for the first time, we will quickly touch on the front end side of things. And it generates also like all the configuration file for DFX, generates some assets and some front-end files like the HTML and the CSS and JavaScript. Okay, so now I can move in and open this project. So I have a Motoko file here, which contains the function greet, so simple function, and a frontend which contains a JavaScript file, HTML, CSS, and this will also be compiled and installed inside the frontend canister. So let's say I do a deployment. I will start my local replica. And then I will deploy. So I will run dfx deploy. What's happening here? Okay, yeah. Sometimes there is a slight delay between the start of the replica and the moment you can deploy. So dfx deploy is going to deploy all my canisters listed in dfx.json. So essentially this backend and this frontend in my local replica. And it's also a good occasion for me to show you a more involved dfx file. So we haven't had too much time to see that, but dfx.json can be slightly more elaborated than what we've seen so far. We've seen this canisters key and then the list of canisters, but so far we only had one canister or two canisters, and it was essentially Motoko canisters. So you had the main and the type. Now here we also have a front-end canister, and it has a little bit more options. So for example, we can list dependencies. A dependencies is a canister that will be deployed whenever you deploy this one. So if I decide to only deploy the front end, I'm actually also going to deploy the backend because the front end depends on the backend. Then you have the entry point for your front end. So in our case, the HTML file. And you have the source file. So the source file will contain the assets and the build of your front end. So this is traditional front end like development, web development. So there is nothing specific about the IC here, but I have this folder comes from my build. And so this is the folder that you need to put in the source, as well as the folder containing your assets, which are the SVG file, some icon for your website, and a CSS file. And then you need to specify the type, which would be type asset. The asset canister is a canister, but it's a specific canister that has kind of a already packaged code. Essentially, it's a canister that is able to serve web content. So there is a HTTP request, and there is a way for you to store files inside of it. And the asset canister is nothing else than storing your files. So storing essentially your build, your JavaScript build, and then serving the JavaScript build once a user accesses the front end. There will be later this week a dedicated session on front end where I dive a little bit more into how to add a login with internet identity, how the asset canister works, and a few other tips that I can give you. But for today, I think that's everything that you need to know. Okay, so now my canisters have been generated, and I want to show you that in the .dfx folder, I have this canister folder, and then if I look inside my backend, for example, I have this did file, which is the Candid file, and the Candid file lists the interface of my canister. So just like, wait, remove that. Just like it was specified here, a Candid file is a file with the .did extension, and we can define the interface with the did file. Good thing for us, using Motoko, the did file is automatically generated. So whenever you have a Motoko actor, it can be as complex as it can possibly be. It will always be automatically generated for you by the Motoko compiler, this did file. It's not the case for every languages. So if you are using like Rust, if you're using other languages, you would need to have some toolings, or you could also have to do it manually to generate this file. But for Motoko, we are lucky to have this. Yeah, so also Candid contains I would say the vocabulary and keywords that are specific to the IC. So you won't be surprised to find the query, which is also a descriptor in the Candid syntax, because this is a query function. And as I said previously, the types in Candid are closely related to the types in Motoko. if we take a look at the main.motoko file, here we have the query, we have the text as an argument and the text as a return value. And here it's the same. It's just that text has become text without capital letter. Okay, so we have already seen how to interact with a canister. And Candid is actually very useful for communicating with canisters from different places. So we've seen how to do it from the dfx command line. We have also seen the Candid UI. The Candid UI, you have the local Candid UI. So right now, this is my local Candid UI. Here you can see that this is my local IP address, so 127.0.0.1. This is the port that the dfx deploy canisters on. And then you have the canister ID. So this canister ID is the one of the Candid UI. And then the second ID is the one of the canister that I'm looking at through the Candid UI. So if I just look, this is the Candid UI, then I can paste this canister, which is my backend, go to it, and I can see my interface. This is locally, and every time you work locally, you will have a local Candid UI that is deployed for you. But if you work on the IC, there is a Candid UI for the IC as a whole. I can also share the link in the chat, which you can access. And you can provide a canister ID here. So let's see, what would be a good example? Maybe the Motoko Bootcamp dashboard would be a good example. So I could see this one. And assuming that the Candid file is available out there, you can access the canister, the Candid UI of the canister of your choice. So you can see here that all the methods that are available on the dashboard, and we can even like call some of them, maybe like remove, maybe add admin, like me. Hopefully it doesn't work. Yeah, doesn't work. So that's great. This is similar to, of course, what you have on the dashboards. The dashboard is actually leveraging the Candid system behind the scenes. So you can also access that from the Internet Computer dashboard. But the Candid UI is, I would say, the most raw way to access a canister interface. If you don't have the Candid interface, so if the DIT file is not out there, you might not be being able to access the canister. So it's the case for a few canisters that are not written in Motoko that this file is not published. And that can make like looking at your interface a little bit problematic. So in that case, you would need to either provide it manually, so ask the developer, or find a way to look into their repository and to generate the DIT file. I can see a question about Rust. Can you generate the DIT file from the CLI in Rust? In Rust, there is a tool which I think work in like most of the cases that can generate the code for the DIT file for you. I don't remember the name of this tool though, but it should be easily find. You can easily find it from the Internet Computer documentation. Okay, so that's the Candid UI. Of course, we also have the terminal, as I said, and finally, we have the front-end way to interact with a canister. So through a JavaScript agent, and the JavaScript agent leverage the Candid UI, the Candid file. So here, if I look at all the files that are generated for me, not necessarily in .dfx, even if we could find those files in .dfx, but there is something that I want to show you, which is this new file called declaration, this new folder called declaration, which contains the declaration for the backend and the declaration for the frontend. And here you can see the Candid file, but you can also see this candid.js and this candid.declaration.typescript. So essentially, this is a generated JavaScript file that you will use in your front end, you will import this file to be able to communicate with your backend canister and with any canister. And this one is necessary if you want to use TypeScript and you want to add type support to interact with your canister. So let's take a look at how it's done. If you take a look inside the index.js, it will give you quite some indication about how it's done. So if I look at my package.json, and here I hope that everyone is familiar with basic of the front-end kind of world. If you are not, package.json is a file that lists modules that I'm importing in my front-end code. And so I have those dependencies which are imported and used in my front-end code. And you can see the packages that I have, which are all from the Definity organization, Definity agent, Definity Candid, Definity principal. The agent is a software that enables us to interact with the internet computer. And you have agent from many languages. Of course, the most common one is the one that you use in JavaScript, but you have agent for many like different languages. And actually, I think there is even a grant program that is specific to developing agents for many systems and many languages. So if you're interested by that, you could build agent and get paid for that. So in my index.js, I'm importing the actor class and the HTTP agent class from the Definity agent. And here, create actor essentially create a JavaScript object that contains all the methods of my canister. And I can use this actor to call my backend from the JavaScript side. So if you look at it, we could take some time to read all the details of it, but essentially what it's doing is you need to specify the canister ID. You need to specify which environment you're running on. So if you're running on local or mainnet, this is done through environment variable here. And then it's just returning the actor. And it's also using this ideal factory. So essentially interface description language factory, which comes from the files that we've seen previously, which is here. Here, ideal factory is an object that is returned here. And if you look at it, it's essentially returning the interface of our canister. So let's quickly try to access the front end. So it's here. That's not what I wanted to have. Let's see, maybe I can. So I'm starting a development server to be able to access my front end. Okay, this is my front end, and I can communicate with the backend canister through this application. So for example, if I put my name, it's going to query the greet method on the backend and returning the results for me. We can take a look at how it's done. If we look at the front-end side of things, so I'll quit this. We have, oops, it's in the front-end folder source. We have this index.javascript. As you can see here, it's importing the backend from the declaration folder. So the one that is the one that we've seen before, the index.js that is here, this one. It's importing the backend directly from it. And then nothing more than just calling await the backend and the method name. So just essentially very similar to what we've seen in Motoko. Maybe what I can show you is the actor. So what the actor that we've defined looks like. So if I just do this, we can take a look at the console. And if I call this, I should see actor. So I can see my actor object. And you can see that this is the JavaScript representation of this Motoko canister, which has all the methods on it. So, well, there is only one method here, grid, but if I had more methods, of course, those one would be listed. And you also have access to the agent that you're using. So the this software that enables you to communicate, the canister ID, and a few more information about the canister and the actor. So that's it for the front end, at least for the Candid side of the front end. Yeah, we will do the integration with the internet identity later. So I think that's enough for today. Now, there are a few more things that I want to talk about Candid. So where is it? I got those are all the available agents. So you have a JavaScript, TypeScript agent, Rust agent, .NET agent, Dart agent, Go, Java, Python, C, Ruby, and so on. Ruby, sorry, and so on. So if you want to take a look. Now, a few more things about Candid. Since it's a technology that is kind of custom, it can be hard sometimes when you run into situations, edge cases. You might need to use some related toolings, and I want to talk about them. So the one that I've been using the most is this DIDC. So it's a Candid CLI. Sorry, it's a CLI tool that you can use with Candid. Really easy to install. And then once you have it, you can do encoding, decoding. You can do generating random Candid value. You can also test interface. So if you have two Candid interface, you can check if they are compatible or not, meaning can I upgrade my canister with the previous interface to the new interface without breaking clients? And you can do that through this Candid CLI tool. So I wanted to mention it for you, this DYDC. I found myself using it quite a few times, especially the encode and decode part. I think one trick that I wanted is this one that I've used in the past is if you do a call to a canister, you have a flag that you can add, the fx canister call. Output. So if you do Candid backend grid, yes, if you do this, you will receive the raw, I would say raw Candid object. So you can see here, this command can be super useful, especially if you combine it with this tool. I guess this is, yeah, it's a similar encoding, at least in the beginning, if you take a look at it. So we can probably guess that this encoding essentially is a Candid kind of signature because we can find the same here. And yeah, it can be super useful to use that. If you want to dive more into understanding how Candid work, I wouldn't recommend those lectures if you are not planning to build developer tooling. So that would be specifically for the people that would like to build developer tooling on the IC. If you would like to build developer tooling on the IC, you should really understand Candid, like deep dive, how it works. So, and I would send that in the chat, Candid from engineer perspective, and Candid from, I would say, more of a mathematician perspective. So this one, the second one, is really rough, as it's said here. But if you really want to dive into how it works, because there is a whole theory behind this Candid language, especially for the safe upgrades, you can read this series of articles. You have 5 of them, and they go crescendo in terms of difficulty. And they give you a really good perspective on Candid. So that's in the chat right now. And I think we are good. Most of the time, the rest will be abstracted away. So that's all I have on Candid. Is there a question on Candid? I've touched on the Candid UI. This we've seen. This we've seen. Yeah, maybe also this repository that contains a list of all the possible tools that you can use with Candid. Okay, so yeah, that's it for Candid. I don't have more to say. I think we covered everything that we need to know. And if there is no question, then I guess now it's time for you to go on the project 4, so I can already give some direction for it. Project 4 is the voting system, slightly more complex than the one we've done before. There are quite a few requirements that you need to follow, and also for the first time, you have less guidance in the task. You will notice that you only have 5 tasks, but you don't have the as detailed task that we had in the past. All the types for the proposal are already defined for you. So just to maybe clarify a little bit how it's done. A proposal is going to have a score, which is going to be integer. And let me take a look. Yes, so a proposal will have a score, which essentially is increase or decrease every time someone votes. And the voting score of voting power of a person is determined by the number of tokens they have. So you would need to use the previous project where we built a token. And essentially, if you vote for and you have 10 tokens, then the score is increased by 10. If you vote against, it's decreased by 10. And whenever the score of the vote reach 100, the vote is automatically accepted, or the proposal is automatically accepted. If it's minus 100, it's automatically rejected. And if it's accepted, you should essentially implement the proposal, which can be one of the two here. So either adding a goal to your DAO or changing the manifesto of your DAO. I think that's all that you need to know. Then the requirements are all, yeah, here. And they are all specified here. So you should follow all those requirements. Only members of the DAO. So you will need to use the project 2 as well to know if members are inside your DAO or not. By the way, this is the first time that we are bringing back projects. So before the previous one, you were doing project 1, project 2, project 3. They were still following the DAO progression, but they were not leveraging the code of the previous project. In this project, we need to bring back, which is something that I've already done for you, the code of the previous project, because you will need to essentially leverage that for today. You will need to interact with the code that is here. Okay, so that concludes our session. I see you in 1 hour and a few minutes for the project number 4. Good luck, good afternoon, and see you in a few. Bye.